ain't good enough. You're out of compliance. And you lock it down, and you don't touch the system once you get to 99.999. And you work every day to make sure that that system produces repeatably with zero variability. So when you take the digital, which is used to failure as an option and constant iteration, and you overlay it with a system where we've been taught low variability and high quality is the output, you get a clash of two worlds. But those worlds are coming together, and we all have to move faster and understand how the train car moves at one pace, which is the physical, and stays on the tracks and is repeatable, but the digital runs back and forth inside the train car and learns all it can while we go. And so that's what we're here to learn about today with Bosch. I'm going to turn it over to Chris. Thank you, everyone, for being here. Thank you, Chris, for being here. And I hope we have a great session. So thank you, guys.
I think I have a thingy. Yeah, good. Yep.
Oh, and I would ask one last thing. If anybody has a question, I'm going to leave the mic back there with you, Kristen. I'm going to leave the mic with Kristen. Please make sure you get a mic, because when we live stream, people can't hear the message. We have the OEs all tuning in. And they want to hear. The engineers at the tier ones and the OEs tend to tune in and listen to this. So please use the mic. Thanks, Chris. Have a great day, everybody.
Great, thank you. Can everybody hear me? Okay. Also, thumbs up for live stream thingies. Yeah, let's just go with assuming yes. Tom, thank you very much for the kind introduction. It's also my pleasure to be here today. Also, on a little bit of a sentimental note, I'm originally from Buffalo, New York. Western New York area, but I spent a lot of time in Troy, of all places, because my family moved here part of my family moved here back in the day. So it's always a pleasure to be back in this part of Michigan, especially now that the Rust Belt is back, baby. So this is it's really exciting stuff, and great to see that so many of our communities are kind of recovering in a lot of ways. So I'm here from Bosch. I'm specifically here from Bosch's Research and Technology Center, which is a R&D organization that we launched nearly 20 years ago here in North America. So I'll just take a little bit about that, and then we'll quickly get into the technology and some of the different applications that we see across several different domains. I was talking to some of you, so this isn't just about automotive. It isn't just about one particular vertical within manufacturing, but some of the things that we're doing around applying machine learning and this overall buzzword of artificial intelligence to audio, to one of the critical, the most important senses and most important sections of information and data that we have out there. So just again, a little bit of, it sounds a little bit of Bosch advertising, but it is not intended to be. Also maybe a couple of things about what the presentation is not. I don't want to get too heavy into say the math and the fundamental technology. I'll highlight a couple of different approaches and where we're going here, but this isn't intended to be a PhD dissertation on machine learning or deep learning or any of that kind of business. There's enough stuff out there, and I'm not even that smart to explain it anyway. This is also explicitly not a sales pitch. I am, as part of R&D, I'm a cost center. The profit center gentlemen are over there. They will happily sell you something. I can't sell you something even if I wanted to. So this is really about a discussion about the technology and opportunities about how we can potentially grow and look to apply this on applications that are interesting for us. I think we also, as Tom mentioned, as we were talking beforehand, this is stuff that we're doing right here in the U.S. and want to apply right here in the U.S. I think we see a lot of opportunities to do that right here, and a lot of opportunities both in the pre-competitive space as well as in the application space as well. So, actually this slide is a little bit, these numbers are a little bit out of date, and if anybody wants to learn more about Bosch, we have the annual report. Something that I'm not sure how many of you are familiar about with Bosch, it's one of the weirdest companies that I know from a governance structure. We're effectively sort of owned by a charity, right? So the Bosch Foundation owns the company. And we also have tons of employees that make stuff, right? So now that number of 389,000, it's actually 430,000 associates all over the planet, something like this, right? And so in many of we don't contract out our manufacturing. Many of these associates also make stuff. So we're actually very active on the industrial application side of things. And also I think there's about 40,000, 35 to 40,000 of us in the United States, spread over many states as well. And so and these are the different business sectors that we work in. So it's a very diverse portfolio of whether it's in, of course, Bosch being most famous for being well, I don't know if most famous, but certainly well known for being the world's #1 automotive supplier, but then also active in many different sectors. Many of you might know us also from whether it's power tools, appliances. If your dishwasher broke, I apologize, it's not my fault. I do know how to fix them now, though. And then, so consumer goods and being much more active in getting our name out there. But then also, especially in industrial technology. And so our colleagues here from Bosch Rexroth, and as we say sort of in the software world about eating your own dog food, we really strive to lead or to apply our own learnings internally around many of these things around Industry 4.0, learn from them, and then that gives us the credibility and the expertise when we go and talk to external customers about how we can work together and apply some of the technologies that we're developing in that area. So I'm part of corporate research, so I'm manager Weenie Boy, but I'm part of the Egghead crew. So it's my privilege actually so we have about, out of those 425, 430,000 employees globally, there's about 1,600 of us all over the planet. And it's our job to invent the future of technology for Bosch. And it's across all those sectors. And it's also looking at new business sectors that maybe Bosch is involved in already. And so just a couple of different things about the locations, again, global footprint. I'm responsible for the office over in Pittsburgh. And our focus there is around cybersecurity, as well as AI applied to the IoT. And I'll talk a little bit about, that's of course what the main talk about today. And again, just a quick little thing here is just to say that Bosch, I think, is also, we're opening up a lot more, right? I mean, I think in the past we've been known very much as a quiet company, a very insular company. And I think now we're realizing that open innovation, working with the best on the planet is really the key to success. And so in Pittsburgh, for example, our partnership with Carnegie Mellon University is really critical. So that's our CMU. I've got a funny CMU and CMU story later on about the internet if anybody cares to ask me about that. There's a reason why Carnegie Mellon ended up with cmu.edu. But anyway, if anybody cares. And so, yeah, I think that the main themes that we look at here, again, it's just all this stuff, and I think it's more of a little bit of a European term. We talk about, VUCA, which is this VUCA world, right? Volatility, uncertainty, change, and ambiguity. So how do you plan for a future when you've got to get 99.9999% right, and then tomorrow what you just got right isn't really the right thing anymore? So how do you plan those investments? How do you plan for that change? How do you live in that world? How do you innovate in that world? How do you partner in that world? And so we try to bring all these different megatrends, either from say from socioeconomic, but also technology. Again, we're technologists. Pretty much everybody in my team, the proverbial smartest people in the room, right? PhDs in computer science and computer engineering. But are we inventing the right things, right? Are we going after the right technologies? And so we try to frame this discussion and look at around these main themes. And I think it's certainly no stranger for everybody here in the room in Michigan, with you guys being the global leader in automotive technologies. But so many of our leadership, our colleagues talk about not just being a car company, but being a mobility company. And so these themes around automated, electrified, connected, are things that sort of our guide rails for the things that we do. And then also living up to our motto, which is Bosch is invented for life. How do we do that, especially around things like societal change and in the context of automation, which is coming, which is again the theme that I'll talk about right now. Again, now if we start to get a little bit more into why AI, right? Let's bring from the buzzword down to something a little bit more tangible. From our CEO says that basically, very soon everything we make will have some sort of AI capability, or will have some sort of be influenced or be affected by AI, which is remarkable, right? I've worked for Bosch for almost 20 years now in different capacities, and one of the reasons why I was trained as a computer and electrical engineer, and I'm a thing guy, right? We make stuff, right? Software, we make things. And so now the fact that, there's that famous quote by the guy that, by Mark Andreessen, about software eating the world, right? Software is starting to eat all of our stuff. And this is one example of, if they're saying, hey, listen, how can we imbue our things with this intelligence, and what does it mean? What is the value that it's delivering? And so, also, the guys are actually former former CEO, sorry, Brian, of Intel, talks about, there's this World Economic Forum report that was probably 2010 about, data being the new oil. But I like this quote from him is, oil doesn't have, well, it is only really valuable once it's refined. And this is the kind of thing where you see all these, I have to admit, I'm not sure how it is on public roads here in Michigan, but in Western Pennsylvania or California, or even the tragic accident in Arizona, you see all these self-driving cars driving around and collecting data. But how are they making sense of all this data, right? Just because you've got a point cloud, 50 million point clouds of the same street, what are you doing with it? How are you making sense of that data? So it's not just about collecting data, it's how do you refine that data, how do you make sense of that data, and then what are you doing with it? And then this is, again, I think kind of you showing an Intel slide around automotive data here in Michigan is a little bit pandering. But just the kind of thing where we're talking about 4 terabytes every day from a vehicle, right? What are we doing with all of this stuff? And I think this is just a little bit of a theme that I want to share with, and now that we're going to start to get a little bit more into the details of what we're doing, and I would like for you guys to think about this, and this is an opportunity that I think that we have to potentially collaborate, to work on pre-competitive R&D, to try to get at some of the hearts of the problem. And so this is the theme of this slide shows that everybody wants to develop this next sexy algorithm, and you will hopefully, I don't know, not sexy algorithms, but you will certainly see some of the algorithm work that we're doing around AI in the coming slides. But it's not just about the algorithms. So if you look at some of these really famous, I would say, applications, whether it's stuff like IBM winning at chess, or Watson in Jeopardy, and all this kind of stuff. It takes around almost 20 years, 17 years, from an algorithm being developed in some of these machine learning fields to being actually deployed in, say, a production quality application. But once you feed these algorithms with data, with meaningful data, the acceleration of them being actually able to meet new performance targets is really remarkable, right? So it's 17 years from the invention of an algorithm until it really is able to do some damage, but it's only on the order of 3 to 5 years, where if you feed it something like Wikipedia, right, you can beat a Jeopardy champion, for example. And so this is the kind of thing where we see where it's not just the algorithm development, it's also the data, and then finding the right application that really delivers value and the promise on all these things. And so this quote, I think, again, is something that we should think about, is it's not just about the algorithm, but also it's the data sets, the high quality data sets, and the information that's really the limiting factor, that could be one of the limiting factors in the widespread deployment of AI. Again, just a little bit of, I guess, kind of advertising. I'm not sure if it is or not. But so in order to tackle this problem, Bosch established something called the Bosch Center for Artificial Intelligence. So this is a part of our global organization, and it is intended to emphasize our investment, the importance of AI for Bosch. So I mentioned I'm one of those R&D weenies, and something that I'm really proud of is that in Pittsburgh, so it's not here in Michigan, but it's, I just drove it last night / this morning, 4.5 hours away from here. It was recognized that here in the US, we have some of the best capabilities around AI R&D, so we're partnering together with Carnegie Mellon University. Of course, up here, you guys have also incredible places like University of Michigan, just as one example, is really leading the way in these areas. And to really push on a couple of different themes, in which some of these topics you may have heard of before. So the example that Tom gave earlier, like 80% is fine. 80% is not fine when you're talking about safety critical applications. Or, hey, this thing ran into something, whatever, I don't really know why that happened. No, that's not okay. You need to be able to talk about explainable AI to kind of peel back the curtains and understand. Think about the Toyota unintended acceleration cases a couple of years ago, and I mean literally federal level investigations into why this happened, right? And going through, and it was complicated, but actually just by coincidence, my advisor Phil Koopman at CMU was one of the experts that went through the code. It was kind of the spaghetti code disentanglement of these complex systems, but humans could understand it. as opposed to some of this AI stuff where you feed it into black boxes and you're just like, I don't understand what's going on there. So it needs to be robust, explainable, and then also all these other challenges around more traditional robotics, on how do you teach a robot to go from here to there, or what decisions they should make, or act in a safe context. So a bunch of different really cool themes that I think are really, really interesting. So I'd like to now... Yes, so the two lead applications are really around manufacturing and autonomous driving. So for sure, we look at it, so the things that I've mentioned here is what my team will grow in Pittsburgh around research. But my colleagues also over in Germany, is also in Silicon Valley, have gotten a really great head start working together with Bosch plants all over the planet about driving efficiency and cost savings and looking for new opportunities for automation. And so manufacturing for sure, but again, being the world's largest automotive supplier, autonomous driving is coming, right? And so we're looking at ways also to apply many of these new technologies so that we can also be, to continue to push on our lead in safe and robust autonomous driving for sure. So let me now go into a little bit more detail about some of the main theme about today's talk around audio analytics. Just a quick picture of the team again, some really great colleagues I get to work with, both primarily here in the US, but we also are able to recruit people from all over the planet that want to come to work with us as part of Bosch's global presence in our lab in Pittsburgh. So we're really able to get access to really great talent. And so just to kind of talk a couple of different themes here. So why do we care about this? What's the business case? A couple little bit of some hopefully cool videos, and then maybe some stuff about how we look at it going forward. And one of the also the privileges of working together with a place like CMU. Is that one of the fathers of AI, like literally the guy that wrote the book on machine learning. His name's Tom Mitchell, and he was at our facility maybe a year or so ago, and we were talking about this technology, and he says that computers have been sort of deaf and blind for since their inception, and now they're finally being able to see, right? You type in something Google image search, cat soup automation alley, and you'll get an image that's pretty close to that, right? That we have all of this. We have that capability at our fingertips to be that now computers can perceive, and the rapid advances in this that was just compared to even 5 years ago is really incredible. And this is really one of the success stories around machine learning and artificial intelligence, even just on a very basic level. And so, but now what does it mean for hearing, right? One of the basic senses of our 5 basic senses as humans, right? What's the equivalent of saying, hey, what is a 1986 Ford Thunderbird V8 sound like? Or hey, what does this machine sound like when it's operating properly? Like there's really no analog, there's really no equivalent, on the audio side of things, and we think there's a huge opportunity there. And so, if we think about what is the sound of things, and this is certainly inspired by the success that we've seen in computer vision. And these are just a little bit of the numbers, and we see that this was inspired also. I'll link this back a little bit to what we talked about data sets. Is if you look at things like, back in 2010, at 70%, this isn't really, industrial grade performance kind of stuff. But you start to see some of these applications of deep learning technologies combined with a particular, with a data set that was released that had tens of millions of images associated with it called ImageNet. And so this is a publicly available data set that was labeled, this is a cat, this is an apple, this is a car. And then you could take these massive amount of data and feed it into these machine learning algorithms and teach it. This is what an apple is, this is what an orange is, this is what a car is. And then it can start to learn in that way. Same kind of thing around some new work on audio recognition, which is also exploded. That allowed, even though we all still make fun of Alexa and Siri, you know, these are, it's when you're the most, when the Echo is the highest selling product on the most, the most successful retail platform in the world, there's something there, right? So, you know, you start to see where this is a word error rate, success rate here, so 95% accuracy. You know, this is also, you know, when we start to get up above 95, 100% accuracy, that's literally what they call human level perception, right? You know, the performance of something like Google image search on basic images is basically equivalent to human recognition. You know, so what's the equivalent in audio, right? You know, do we start to see some basic capabilities coming there, and what does that mean? And so, you know, also if we think about things like autonomous driving or in the manufacturing space, you know, how can we augment human perception? How can we build this into a capability for a couple of different use cases that maybe I'll talk about a little bit later too, if we have time, around things like being able to, you know, when you drive, there's a reason why you're not allowed to put headphones on and just drown yourself from the outside world, right? It's one of your important perceptions of what's going on around you, whether it's an ambulance or whether it's a car fast approaching or any of this kind of stuff, right? So this is a way that cars need to be able to hear if we're going to turn them loose on humanity. So, you know, what we want to do is to look at what are the highest potential applications across different domains. Again, remembering that Bosch makes a lot of different stuff. And so you can imagine things like, you know, whoops, no, there's supposedly some sound. Okay, there's a sound. So whether it's things like environmental sound, so Bosch also makes a lot of technologies around for building technologies, so intrusion detection, video cameras, and also some access control, right? So what if we can move beyond just our video camera, but what if there's a chance also for us, I might want to turn this volume down so that we don't kill you guys again here. So what if there's a way to augment our current portfolio, and for example, for the security guard looking at a video, what if you can tell him or her what's going on in the room rather than just having him look at a video? What if you can annotate it with what's understanding from sound? Right, and so this is a little bit out of sync here somehow, but you know, but also things like machine sounds, right? So if you're either listening to something like a compressor or electric engine, or that sound is a diesel injector motor for an engine, right? You know, it's the same kind of thing all of us do when something goes wrong. Hey, do you know what's going on with, you know, my car or, you know, my HVAC blower? It's making a chakong, 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 chakong sound, right? You know, what if you can translate that into actionable information that rather than calling up your buddy or the guy you know that fixes HVAC, what if you could take your smartphone up next to it and say, hey, what is this thing? What's going on? And it can give you some advice. And then, you know, also different sounds that we all make, right? You know, whether it's things like, you know, activity recognition in the home, or, you know, footsteps, or being able to just being able to better understand the human activity in a room. And so there's a bunch of different, you know, even you mentioned about healthcare applications as well, which is not one of our focus at the moment. But you know, this is one of those things where we take a look at these areas and say, hey, look, what are the ways that we can develop algorithms that then we can feed different data sets or different applications and look at different verticals and see how it can be applied. So I'll just kind of go through this again. I highlighted a little bit already, but like, you know, whether it's things like for physical security, and I'll show a video about that later on. But again, also for automotive, a really critical way to complement what we're doing with around video, and then, you know, finally, really about machine monitoring, which is really what we see as one of the critical or the most important opportunities in this area, and also for Bosch, right? So you want to be able to understand what's going on in these complex machines, right? Whether it's airflow, or whether it's, you know, it's gears turning, or whether it's electric motors, or any of this kind of stuff. Things that you can characterize, and then you can understand when they're not performing correctly, and then you can then over time we also can see how things degrade. And this is the kind of promise around predictive maintenance And then also, as Tom said, hey, listen, don't preach to the choir here around Industry 4.0, but then if you can also integrate this into different Industry 4.0 workflows or technologies, is there a way for machines to self-diagnose, to bring that into a maintenance or an OEE workflow or this kind of stuff where we can understand better to improve the overall performance of a plant or of a production line. So what's, and for the way that we came at this, and this work started 5 or 6 years ago, we're looking at it from an IoT perspective. So why now, right? And so if we look at the falling cost of sensing, right? So we all, whether we like or care or care, are carrying around bunches of microphones in our pockets, right? Like I think this phone has 6 or 7 mics in it already, right? How many? There's also in an Echo, there's Amazon Echo, for example, there's I think 8 or 9 microphones in an array microphone in it to improve the performance. So there's a falling cost of sensing audio, which is everywhere. There's this chunk, which is the sexy machine learning piece of it, and then also this connectivity and this balance of what do you want to do on the device itself, and what do you want to do maybe at an edge, and what do you want to do on the cloud remotely. We were talking a little bit just at the start of this too, and they need a balance. I saw one of the previous, oh, there you go. So one of the talks coming up is this debate for when you're looking at cloud computing. What do you want to do on the premises, and what do you want to do remotely? What do you feel comfortable, for your business risk? And that's the kind of thing too, where now we see technologies where we can then package this and deploy it and put it on a particular device, or we can also provide it as a service where somebody could access it over the cloud, for example. And so this is really what our this piece around machine learning is I think the kind of the part that we want to talk about a little bit more detail today, is to this pipeline that we see for applying deep learning in some of these, collecting these data sets, and also these deep learning, machine learning pipelines, and the performance that we're able to see in leveraging some of these technologies. And you also see that there's a bunch of different players that are waking up and recognizing this. So smaller, medium-sized startups, but I guess you're not that small or medium size anymore when you're talking about investments of several millions of dollars in Series A and potentially Series B investments, and also not just in general around physical security, but also around specifically around machine monitoring and Industry 4.0 applications as well. So you start to see really some really interesting proofs of concept, and I don't know if I would call them production grade, but certainly some market player or some entries into the market here. And this is now to come back a little bit to this earlier theme I mentioned around the data that we need to feed these pipelines, these technologies. So as always, our friends at Google now, and they are pushing a data set that they have collected that was based on YouTube videos around generic sound events. So it would be something like a car driving, or something like footsteps. But it's also kind of what we call a weakly labeled data set. So if they say, hey, give me a quick clip around footsteps, it's like a 30-second clip, or maybe 15-second clip, and somewhere in there is footsteps. So we don't even have high-quality data sets yet, certainly not at the point that are analogous to what I mentioned earlier, that ImageNet thing with the millions of images that led to that explosion. We don't have these data sets yet that are able to allow us to do the explosion of performance that we saw on the image side of things. And this is also something that we want to push on together with the larger community and potentially that we think that we could drive innovation in areas. Also potentially, and this is something where industry groups or consortia can come together, maybe not necessarily around footsteps, but perhaps around electric machines or around airflow or something like this, something a little bit more domain specific. So maybe just a little bit for people that this is where I'm not really sure if I'm either going to get people interested or I'm going to lose people. So why don't I skim a little bit, and then we can decide if we want to go into this a little bit more or not. The innovation that we're doing on some of these different algorithm side of things, it was pretty much back in the day, 5 years ago, was inspired by speech recognition technology. So we basically took kind of the state of the art in advanced speech recognition and fed it audio data, right, and see how it did. And so a pipeline kind of looks like this. There's these, they're called septural coefficients, where you basically take an audio stream and you kind of slide a window over it and you feed it into this, into the model, and then you basically look for like, hey, this sounds like this word. It's very likely. You just look for the peaks in this Gaussian model, and it says, hey, Chris is saying this is a word, right? And so then you're able to say, pick out those, the hits that have the highest probability. So that was kind of state of the art back in the day. And now you start to see, then we said, okay, listen, around all this kind of sexy deep learning stuff, you know, let's see if we can take advantage of the work that had been done in image recognition. So what if we take audio and then transform it through FFT, whatever, into an image, and then feed that image into an image recognition pipeline, right? So, you know, the image, or the audio data then looks like, that's a spectrogram and then just feed it and see what happens, right? Yeah, it works. We're pretty good, fine. But then, you know, then also we said, okay, let's stop playing around here. Let's take the audio file and build a custom deep learning pipeline, taking that audio file and then learning directly on that. And then this is now where we're starting to see, you know, the results of the innovation on this here. And so what you see on the left is there are these custom deep learning pipelines which have been built that really take advantage of the domain knowledge learning. I will not do that. I don't know how to do that. And I'll talk about audio, and I don't know how to control the audio in a room. Okay, define irony. Okay, I will just not go near it. So it uses the domain knowledge, knowing how basically the voice pathway works. So they're now they iterate on these things, and you sort of build these layers in the deep learning pipeline, knowing how taking into account how the human physiology. And then is there a way where we can do the same thing, where we take into account, hey, what do we want to learn about? Is this taking the domain knowledge of the physics of the sound that we want to learn? And so the things that we call this kind of a physics, we call it a physics grammar, right? So let's take an example of a quadcopter. I think I have this video, I'm not sure. But, so, you know, the quadcopter isn't really a whole lot more than there's you've got, you know, 4 spinning rotors, and that you can kind of, you can actuate them in different ways. And so, whoops. Yeah, so, you know, what's going on here? You basically have plastic rotors that are spinning through air. And by understanding that you're talking about, you know, the interaction from material A and, say, environment B, you know, how can you feed this into some of these different pipelines and learn about it? And so, you know, and then also, can you say, hey, listen, if I want the quadcopter to go this way, you know, then how can we learn about how we actuate those different fans in order to do this? And so basically what you have going on here is you can, by understanding how these industrial machines are interacting with the environment, then you can build a pipeline recognizing what's going on here. Maybe I can show this a little bit better with a video that we made to kind of show the power of this. Do any of you guys know that, so Bosch makes 3D printers? Anybody happen to have a Bosch 3D printer? No? Okay. Bosch, we own the Dremel brand, and so go out and buy a Dremel 3D printer. It's very cool. And so this is also illustrated by the way that a 3D printer works. So when it boils down to it, a 3D printer is basically a couple of stepper motors and then an injector, right? And a heater for and this is a plastic. I'm talking about PLA for plastic, basic 3D printers, right? So you're basically moving the stepper motor around to lay down the 3D print, and then injecting plastic and heating it such that it'll build the print, right? And so we tried this theory to say, let's see if this plays. Right, this is what a 3D printer sounds like. Right, right, you know, pretty straightforward. So, I'm sorry. All right, so you know, this is a video of what the 3D. If you listen to the 3D printer, this is what it sort of looks like, right? So the path is the graph there is the way that it's moving through space, and this is a spectrograph of what it sounds like, right? That was the kind of thing, right? So when it moves like this, it's a I just made a Close Encounters of the Third Kind reference by mistake there, but right. So and this is what, you know, so those different stepper motors, as they move, they generate different sounds, and so we had this theory. We said, well, by listening. Here's a pic. So you'll see the motor moving around there, right? And now, so intuitively, you can say, huh, I think I can distinguish when it's going left or right or up or whatever. So we had a theory on whether or not we could recreate the shape that the printer was printing by listening to it. And it turns out you can. So this was the actual print that we made. This is what we interpreted in our first guess, what we thought it made, and then we were eventually able to recreate this basic shape. So this is what I mean about understanding the performance or what these industrial machines are doing. We were able to, now mind you, this is a consumer-grade 3D printer, right? I mean, let's not blow this thing out of proportion, but think about this for a second. Maybe, I'm not sure if there's been other talks around additive manufacturing, and we can just beam designs all over the planet. We're going to make these things super secure, and there's going to be all this cryptography, and blah, 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 right? We just pointed a microphone at a printer, and all that end-to-end security that we had to transport something from A to B, we were able to recreate that print, or the thing that the machine made, just by listening to it. And so now, what we can also do, let's think back a little bit on this, is, oh, actually, maybe I'll have a, yeah, so let me go to that in a second. But the power of that is, so we can recreate what the printer should be making. So let's take an additive manufacturing process. If there's a defect in that process, by understanding what came out versus what should have come out, we can also say, oh, look, that stepper motor, that was a little bit out of sorts, or maybe that's you know, it's not performing up to the right specification or something like this, right? So we can understand different parts of that industrial process just by listening to how that's going. Let me give you another example. How do I do this without? All right. Hopefully this will work. Also.